Hello and welcome to this new video of Medihead Bridge. In this video we are going to present a new product. The CSC MUX is the Cloud Security Connector Multiplexer for Zscaler Internet Access for Azure Cloud. This product, the main problem that product solves is the lack of scalability of IPsec tunnels on Azure. What I'm talking about IPsec tunnels. When doing tunnels to Zscaler, the recommended method to reach high speeds, 1 gig, is GRE tunnels. But the problem with the GRE and Azure is that this is the official page of Microsoft Azure, is that GRE packets are blocked on the cloud, on VNets. Then it's not possible to use GRE tunnels at all. And the only solution is to use IPsec tunnels. But IPsec tunnels has another limitation, that is speed. When doing IPsec tunnels to Zscaler, this is the official page of Zscaler, the limit of the tunnel is 250 Mbps. And if you want to do to have more speed, 1 gig or 2 gig or something like that, you need to create multiple tunnels, but in one particular way. You need to create tunnels from different public source IP. Then what Zscaler is saying here, you need to, if you want to go with 500, you need to configure 2 primary and 2 backups. And if you want 750, blah, 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 blah. The problem, if you want to do this manually, of course, firewall can do multiple tunnels, but normally the tunnel is from one subnet to another subnet. For example, subnet 10.1 to 10.2, 10.1 to 10.3, 10.1 to 10.4. In the other end, but in this case on Zscaler, if you want to send all traffic to Zscaler, then your destination in the Zscaler side will be always the internet, the 0.0.0/0. Then you need to create some intelligence to say, okay, how are we going to send all traffic to same destination via different tunnels? Most likely you will need to implement some slot balancer. Well, if you want to create this with discrete elements, router, firewalls, everything, that's near impossible. It will be absolutely expensive, and at the end you will expend a lot of time and money. This is why we created the CSC MUX. The CSC MUX comes to the rescue, because the CSC MUX was designed for Zscaler, it's only for Zscaler, but was designed to solve the problem of scalability with IPsec tunnels to Zscaler. And this is the internal architecture of the CSC multiplex. It is a firewall. It's going to isolate your external environment from the internal environment. It's absolutely a firewall. It's also a VPN concentrator because it is generating tunnels from different public IPs to Zscaler. And we have 2 models, one with 4 tunnels, 1 gig, or 8 tunnels, 2 gig, BBS to Zscaler. The CSC multiplex is also a load balancer. We created the load balancer for this purpose. We are not using any commercial load balancer. We created our own for Zscaler. It's a router. And if you're familiar with the cloud security connectors of Medihead Bridge, you will see that all of them has also a proxy inside for bypass purpose. And this proxy allows you to send some traffic direct to the internet from your own public IP. This is for sites, for trusted sites that you need to reach from your own public IP and also Zscaler IPs. Examples like conditional access, Office 365, obviously different condition of access, Okta, or a bank or a trusted provider that's saying I will accept you from this source IP only. Then, in terms of the architecture, you don't need to be worried about this. This is inside the box. From your point of view, the only that you need to configure here is your VPN credentials, your username and password, period. Nothing else. The rest, and select the nodes you want to connect. If you want to connect to some node specifically, if not, the connector will search for the nearest node and will connect automatically. The deployment is very easy. The only thing you need to have in advance is the external subnet and the internal subnet. And that's it. And a resource group where to place these machines. The device is, in terms of how to redirect the traffic, as in all the cloud security connector family, we have the 3 internal IPs. This is your visibility. The first one is the gateway IP. If you want to send all traffic to Zscaler, this is for routing, for routed traffic. You need to put this as your net hop in Azure, and all traffic will go via tunnels. If you're using pack files, then you are going to use the IP number 2 and number 3. The number 2 is the default traffic to Zscaler when you put on the bottom of the pack file. And the number 3 is when you create on the pack file a list of destinations that say I want to send via the bypass proxy. I have an example here of a pack file. We are going to go in detail, but this variable to Zscaler will point to the BIP, and this is the return traffic. And all these bypasses will go via the bypass, and the bypass is via the bypass proxy. This new model, the CSC multiplex, can be deployed in availability zones, or you can deploy on availability sets. In this lab, we're going to create a lab. We're going to deploy on availability sets. And this is the lab we are going to create. We are going to deploy 2 connectors. And from internal machines, we are going to set up pack files. And also we are going to set up the automatic rerouting for a specific subnet. This is when you want to do high availability via routing and say, okay, if this connector is active, send all traffic via this connector, use this connector as a next hop, but if this connector goes down, use this connector as a next hop. Okay, then we have all options available. The good option about when using pack file, the good is because both are active at the same time, you can use both. Then with a little trick on the pack file, we recommend to set up this, and with this little trick, you will balance the odd even IPs, and you will use one connector for odd IPs and the other connector for even IPs. This will allow you to reach 4 gig to Zscaler for web traffic. Then it's a very, very good scalability. Then let's move on. Let's start deploying the connectors. That is very, very easy. As I said, external subnet, internal subnet, VPN credentials, and that's it for the moment. Then I will go here to my availability set. And the availability set, there are 2 plans, the plan for 2 gig and 1 gig. I will deploy the plan for 2 gig. BPS to Zscaler. Just click on accept. Well, it will ask you some things. And here we have the plan. Click on create. And my resource group is in EU, no, US. This is my resource group. The location of the group. Please pay attention to these values. I will launch 2, but you can launch more. If you want to launch 4 or 6, whatever, you can do it from here. The name of the VM, I may have a name of the VM. I will put this name. The template, because I'm launching 2, will create the HA1 and HA2. This is the username. You cannot change the username. And here the password. I put this password. Come on. Sorry. Okay, next. On virtual machine settings, the connector need the 2 gig need for CPUs with accelerated networking. The storage can be any. That's fine. On networking, select your VNet. This is my VNet. I have only one, and I created my external subnet and my internal subnet somewhere. Yeah. Okay, and the availability set, you can create a new one. This will create a new one, or if this availability set already exists, you can reuse this. And please put the values of all domain, update domain of your configuration. By default, this is okay. This is supported on most platforms. Do and review and create and wait for the validation. One thing that may happen is for the validation is maybe you don't have enough CPUs on the region or public IPs. This is the only case that it fails. Then if this fails, more likely will be you will need to open a ticket to Zscaler, to Microsoft and say, please increase my quota of CPUs or IPs. Then click to create, and we are going to start the deployment. Deployment takes a while. It's about 1 minute, 2 minutes, something like that, where you will see that all the interfaces, IP, security groups, everything is deployed. Meanwhile, this happens. Let's go to the Zscaler console and let's create the credentials that we need for these connectors. Let me have this. I will use these credentials. Copy. Okay, add VPN credential. And let me add the pre-share key. And this is for CSC MOX 2 Gbps. US East. Okay. Okay, now I have the VPN credentials created. I'm going to create the location. Come here, location management. I will add the location. I will call CS6 MOX HA. This is in United States and New York. Time zone. On VPN credentials, put the credentials created. And the classic values, Nebel surrogate, force SSL, firewall, and IPS. Save. Okay, and now I have the one credential for all tunnels is fine, and one location for all tunnels. They put all together. That will be much easier to manage. and there is no way to separate. Then I have on this lab, I have a machine behind, and I will access to this machine. And from this machine, I will SSH the connectors for the initial configuration. Then let's take a look if the deployment is done. Okay, it's done. And now I need to SSH the VMs. I will select the VM1 and go to networking. Look for the interface Ethernet 1. This is the internal one, and this is the IP to SSH. Then I'm gonna come here. I will say SSH CSC admin at. Okay, it's not happy because I was using this before. Let me delete the SSH. Let me delete everything here because. Okay. And the password is the password we created for the VM. Okay. This is the first startup. The first startup, it showed me this wizard, this initial configuration wizard. It's very easy to do. They tell me create the VIP location, VPN, create the app before to do anything here, and run the wizard. And I will say yes. You want to change the cloud and node? Yes, there is nothing here. Zscaler 3. I will do manually. I will select the nodes manually. And my first node will be Washington 35 and New York secondary 28. Change the pre-share key. Yes, I want to insert my pre-share key for the VPN tunnel. Is this one, and the email and pre-share key. Okay, good. Take a look. That's good. Do you want to change the DNS server? Normally this is it's good enough, the DNS of Azure, but if you want, you can use your own. For the back file configuration, from the bypass configuration, we recommend to use the back file for the bypasses. We were talking that on our back file we will have this section for bypasses, the information that we want to send direct via the bypass proxy. And in order to configure, because the connector is blocking everything by default, but the connector has the ability to read back files, then the best practice is to create a back file for the connector. Then we are using this. Let me check which is the name of the back file. This. Then I have on my console created this back file. I'm in the wrong place. Trying to go fast. I'm not going fast. Okay. And here we have, well, some this variable is for compatibility purpose, but the connector is reading this. Then it will read these destinations and will apply as allow destinations to go out to the internet. Then I will come here and I will configure the bypass back URL. Do you want to refresh the list? Yes. Here I have the list. Do you want to apply changes? Yes. SIM, syslog. You can send the logs of the tunnels, up, down, all the stuff to your SIM servers. In my case, I have nothing here. And yes, let's implement these values. Now it's going to check if the Washington node is alive, the New York is alive, and if everything is fine, we can apply the changes. The connector will reboot and will back in a minute. Meanwhile, let me configure the second connector. And let's go here. Let's go to the resource group. And let's go to the second connector here. Remember, networking, we need the internal IP, the first IP. This is the IP. And we are going to SSH that IP. Yes. And let's put the password that will. Oops. Okay. Same than before, run the wizard. Select your cloud, select your node, Washington and New York. Let's put the pre-share key. I'm sorry, the email and pre-share key. Not needed. Let's use DNS of Amazon. Let's put the pack URL. Let's refresh the list, and yes, and no, and let's check. Okay, perfect. Well, this will take about 2 minutes to return to 3 minutes, then I will pause the video for a second. Okay, we are back. At this point, I did a login to the connectors and I received here the main screen of the main console of the connectors. The console is similar to the other connectors of the Maidenhead Bridge family. And the first section is the monitoring task, where we can see all the configuration statuses. We can see the traffic on the interfaces. We can do a trace route and latency test, and we can do a speed test. The second section is the admin task. If we want to use the ACC agent as a manager, change the time zone. The bypass proxy, the configuration of the bypass proxy list. That's, you can see which URLs are allowed to be bypassed. And the log information and the configuration wizards, where we can run again the initial wizard. We can switch tunnels in case you, for some reason, you need to move primary secondary, and the high availability wizard to create a configuration and high availability using changing routes. And finally, to update the Zscaler nodes database. What we're going to do here is to explore first. Let's go to the show configuration status. Let's take a look at all the information we have here. Then the first is general information. It's about connector, subscription ID, VM size, model. The second one is about the interfaces, which is the private IPs in use for the external interface and the internal interface. This data is important. This is one of the gateway, CSC gateway IP. This will be the net hub of the machines that are behind the connectors, right? When using this routing, then will be in a scope A. This will be this value, this CSC gateway IP. And traffic redirection options. This is when we are going to use pack files. Let me copy this because we are going to create a pack file with this information. This information is not accurate. This is old. And the next information is about DNS. We are using Azure DNS. Zscaler information, which is showing the primary and secondary. And here, probably most interesting piece of this is the status of the load balancer. The load balancer says I'm using all tunnels are up and using the primary node, this one. In terms of IPsec, here is the full IPsec. This is information provided by the VPN concentrator that say all tunnels are active. And finally, here we have the information that we are getting from inside each tunnel when going to ipzscaler.com. That is showing that each tunnel is reaching Zscaler from a different public IP. This is very, very important because this is the requirement of Zscaler. Zscaler says if your organization wants to forward more than 250 Mbps of traffic, Zscaler recommends configuring more IPsec tunnels with different public source IP. Then we are solving this problem. And then the last one is the information in regards of the bypass proxy, if the bypass proxy can reach the internet. That's good. All good from here. I open another tab with console. And in this tab, we're going to do is to put the show interface traffic for this connector. And you will be able to see the external interface, internal interface, and the traffic inside each tunnel. Then I will put on the external interface here, and let's run a speed test here, and let's go and see how the traffic is going on. Okay, here is starting. The connector has more capacity of 2 gig. It can go a little bit more. And here I can see that it's peak traffic, all tunnels are generating more than 2 gig. And also you can see here the information of each tunnel in particular. In short periods of time, Zscaler allows more traffic, but if you are persistent traffic, the value guarantees 250. As a result, here we have near 3 gigabytes of aggregate traffic, right? Aggregate download between all tunnels. That is very, very good speed. But the committed is 2, right? Don't be over optimistic. Then let's go to the second one. This is the other connector. Let's take a look here. It's also active. It's using Washington and different IPs here. And I will take this information for traffic redirection options. What I want to know is the VIP proxy and the bypass proxy of this, and I will put it here. Okay. Let's do the same. With the second connector, let's do take a look of the interfaces, and let's go for a speed test here. Let's take a look how the traffic it is. Well, that was too fast. Oh, I was checking something wrong here. I'm guessing I'm in the wrong connector here. Yeah, HA1. This is the other one. Let me exit. This is 7. Okay. Okay, then now show interface traffic. And let's go again. If I run the speed test, Now I can see the traffic here and on each tunnel. They need to take a look here on each tunnel. And the aggregate bandwidth is 2 meg and 5. Yeah, it's always a little bit more than 2 gig and 5. It's always more than 2 gig. Okay. Well, we have now the information of the traffic redirection information, the VIP proxy and the bypass proxy. Then what we're going to do now is to set up, this is the normal setup on BDIs. I'm going to set up a pack file for the BDIs, for the machines that allow to use pack files in order to use both connectors at the same time and for web traffic to have 4 gig BPS. Then I will come here to this pack file and I will replace the values for the values of the connector. My first VIP proxy is this one. So replace both. The bypass, I think it's the 6. Yep. Place both on the second connector. The VIP proxy of this connector, the second one, is then 8. And the bypass proxy is the 9. Okay. Then now I have the values of the VIP proxy, primary, secondary, and primary, secondary. And what we have here, remember, depending if the IP address of the machine, or the BDI in this case, or virtual machine or server, depending the IP of the interface, the primary will be this one or this one, odd and even IPs. It will allow me to use both connectors at the same time and to have 4 gig to Zscaler. Then let's create a pack file. Let's delete this and let's add this and let's call CSC MUX availability set CSC pack. Let's do a quick verify. All good. Save and save. And let's say CSC. Let's search for this pack file. I will copy this URL now, and I will back to a machine I have here on the back, that is this one. In this case, this machine, I have this machine on the back. One is using Chromium here, another Google Chrome. At the moment, if I click here, this machine is using is via routing, and this machine is using both via routing. Let me check my route table. This is going via the 48. Both are leaving from the same IP. Let me put the pack file here, this machine. And let's check now. Still using the same. Okay. Oh, I put the wrong. Okay, I'm sorry. I put as the next hop the wrong value. Let me do a quick check change here. It's using the connector. I want to show that the machine is going direct first. Okay. This will send let me correct this one as well. Okay. Okay, this routing table that is attached to the subnet where I have this virtual machine. At the moment, it will take some minutes. This is going direct. It's a firewall direct. It's not yet via the connector. This is not the next hop. It's the connector. It's another device. Then the machine will go direct to the internet and not via Zscaler. Let me cancel this. Okay, now it's going direct. And this is sometimes much better to open a new tab. Okay. Well, both browsers now are going direct. The reason I'm going direct is because the next hop, the default route, is this. That is another exit, is a firewall we have. The first I want to show you is we are going to apply this pack file to a device behind the connector. Then let's go to the device. I will come here to this and let's put the pack script here. And now this machine will go via the connector and this machine will remain going direct to the internet. This is the first step. Depending the source IP of the machine, one channel or another, one connector or another connector will be used via pack files. Then with this pack file, you can achieve 4 gig to Zscaler. Let's move now to create the high availability configuration in order to have a redundancy, next hop redundancy, between the connectors for routed traffic. The configuration is very simple. We need to come to the connector here to go for the wizard. And the first thing we need to do, I will click here anyway, but we need to assign an identity to the connectors in order to allow the connectors to read the other connectors and to read the routing table. As you can see, there's all this red is because the identity was not assigned. Then we are going to assign the identity on the connectors. And let's go first to the first one. This is the first one. Let's go to identity and let's enable system assigned identity. Okay, and I will put a couple of roles for this connector. You can play with roles if you want. I will assign a role on the resource group. Yes, this resource group is where the other connector is placed, and we need to be able to read the other connector. And also we are going to assign the capacity to read the route table, because we need to change the route table to read and write the right table on this connector. Okay, this is done. Now I'm going to do the same in the other connector, in the number 2. Let's go to identity, system assigned, status on, yes. Okay, and we are going to do the same here. We need to allow to read this resource group as a contributor. And to read the resource group where I have the routing tables as a contributor as well. Okay, done. Now I come back to the number 1, and let's go for the configuration, and let's configure. Okay, I need to do the again. Do you want to configure? Yes. Then we're going to change a couple of routing tables. If I go to my routing table, I want to change this route and this route. This route is the default, it's easy to understand. I want to send all traffic now via the connectors. And also we change this one. This IP is the global gateway, global proxy as a Zscaler. Sometimes what I want to show here is we can change any route. Doesn't matter if the default of any value. But this is sometimes particularly important because maybe you have servers in some configuration that you want to send the web traffic via the connectors, but no other traffic. Then, and these servers are the only that you can do is to put the proxy settings, no pack files. And when you put proxy settings, only one value, is not two, right? Then the redundancy here is put the global gateway, and via the high availability, this will be routed via one or the other. Then, for this reason, I'm going to change these two routes. I have the values of the route here, but this is the route name, the route table name, that is here on the top, And the resource group, where is this information? Do you want another route? Yes. I will add the second one. Let's call it server default route. The route table is the same. And the resource group is the same. Okay, no more routes, that's okay. And now it's asking me the computer name of the other in the pair. And this is the computer name. And the resource group. The resource group of the connector is this one. Oops. Yeah, resource group. Okay. Okay. Now it's validating these values, and it will check that if everything is good. And we'll activate the service. The effect we're going to see here is this route table that is with TCP 10.2.9.4 will be moved to the next hop of the connector, number 1, this one. And the next hop of the connector is the connector gateway IP, this value. The route table should move to this value. Sorry. Now it's saying that the route table was identified here, was moved to this next hop. Then if I come here, as you can see now, this is the 10.2 that was changed. The connector is now in command of the next hop for the routing, the route tables, and route names. Let's do the same configuration in the other end. Oh, let's do a quick test. This browser, now if I do click here, this browser will be affected by this route table. Okay, it's leaving for this gateway IP. Now let's move on to the second one, and let's configure high availability in the second one. You want to configure yes, and let's put the routes. Route name. I'm copying the values of the other. Route table. Source group. And let's go to the other one. Route name. Route table. And resource group. Do you want another route? Yes, no. And the computer name of this one. And the resource group. and let's apply. Okay, now if I check the high availability will check each other. And it's telling me that it's using the other connector and it's touching the routing table. Then if I back to my machine here, this machine is using that connector was, and this is what back file that's still using um, the same values. Let's see if okay, let's do something now for a second. Let's try to come here, but this is match the configuration. This is all that we need to do. Let me put the connector 1. Let me stop this connector. It will take some time to shut down, but this is much the configuration we need to do. It's all about to deploy the template. From here, you can deploy this security zones or availability sets. In both cases, you have 2 plans, and if you click Get In Now, you can select the plan. Then you will receive the template, and you need to specify external subnet, internal subnet, name of the machines, and a password. And when the connector is launched, what you need to do is to run the wizard. You will receive the initial wizard where you need to put the VPN credentials. And after what we did is to read the VIP proxy and bypass proxy of each connector to create a pack file with the values to load balance between the both connectors and to do some bypasses. And what next? The next we did is to set up the high availability. Then we will, when checking the routing tables, we will see that the next hop was moved from one to another. And now we have another next hop that is the other connector because we turned off one of them. Then if I come here and I do a refresh, let me open a new tab. Okay, I'm using another exit that is the other connector, and the same should be here. This is using the back file. I don't know why this page is slow when using the same tab. Probably something related to the browser. Oops. And this is also used. As you can see, the high availability works very well, and HCI is very fast. It's not that the user will not notice the changes on next hop or when the pack file changed the values. Well, this is the end of this video, and I hope was useful. But this will allow you to have 4 gig for web traffic, and 2 gig for routed traffic to Zscaler. Thank you very much. If you have any questions or any doubts, please contact us and our support page at support.maydegebridge.com. Thank you very much.